Welcome to this video where I'm going to talk about ITIL4 problem management practice. The idea behind this video is you can use it as an audiobook. I hope I managed in creating this experience. Main important item for the ITIL4 practice management certification is to check the syllabus and study the actual practice. If you've listened or watched to this video, will you be able to pass the exam? No, it will be in addition to the studying you are doing. I'm trying to cover purely the highlights and not trying to cover everything. Just to give you a little bit of a reminder of the things you need to learn. Hi, I'm Beer, ITIL Master and Ambassador. What I'm going to cover in this video. A lot will be me reading from the problem management practice. I will mention the sections where applicable in the topics I'm going to talk about. The idea is to follow the syllabus as much as possible. Hence, the following topics. The key terms you need to know, the purpose of the problem management practice, the practice success factors, its metrics, problem management practice in the 4 dimensions, the capability assessment and development, and recommendations for the practice success. Now, let us start with the key terms. A pretty long list to remember. Problem, a cause or potential cause of one or more incidents. Prioritization, the action of selecting a task which to work on first when it is impossible to assign resources to all tasks in the backlog. Task priority, the importance of a task relative to other tasks. Tasks with a higher priority should be worked on first. Priority is defined in the context of all tasks in the backlog. Swarming, a technique for solving various complex tasks. In swarming, multiple people with different areas of expertise work together on a task until it becomes clear which competencies are the most relevant and needed. Workaround, a solution that reduces or eliminates the impact of an incident or problem for which a full resolution is not yet available. Some workarounds reduce the likelihood of incidents. Known error, a problem that has been analyzed but has not been resolved. Technical debt, the total rework backlog accumulated by choosing workarounds instead of systemic solutions that would take longer. Problem model, a repeatable approach to the management of a particular type of a problem. Problem management. Problem management is a series of activities, responsibilities, and actions that are needed to remove or manage underlying issues. The terms of the problem management practice are described in section 2.2. Benefits for the service provider and consumer. With problem management, we want to minimize the negative impact of incidents or even prevent them from happening. The advantages which the service provider gains from problem management are: due to a higher reliability of devices and services, costs are decreasing and the agreed service level agreements are fulfilled. Reduced losses and costs caused by IT service unavailability and degradation. Fulfillment of the service quality targets. This also leads to the reduced technical debt and more even and predictable utilization of IT support resources. The benefits for the service consumer are: increased reliability of business operations and business services, a reduced business risk, reduced losses caused by business services unavailability, a better image due to uninterrupted business services. The purpose. The purpose of the problem management practice is to reduce the likelihood and impact of incidents by identifying actual and potential causes of incidents and managing workarounds and known errors. No product or service is perfect. Every product has errors which can cause incidents. Errors may originate in any of the 4 dimensions of service management. For problem management, we have 3 phases: problem identification, problem control, and error control. The problem identification is usually the shortest phase. A new problem is reviewed. This can be a reactive problem which was triggered by 1 or more incidents, or a proactive problem which has not yet been impacting the organization but has been identified by the supplier or other sources. In the problem identification phase, the problem is reviewed. If it is a valid problem, it gets registered and categorized, meaning assigning it to the most likely team or specialist to deal with the problem. Problem identification is always reactive to problems. It does not prevent them from occurring the first time. The proactive-reactive distinction refers to how problem identification and investigation relates to incidents. In the problem control phase, the problem is investigated, searching for a root cause for the problem. Not all problems can be worked on at the same time. Hence, prioritization is taking place to investigate first the most urgent or impacting problems. The investigation, however, can take a long time. The focus is usually to try to limit the investigation time for cost reasons. In the error control phase, known problem resolutions are planned to be implemented, changes initiated. If a problem, however, has been investigated and no root cause has been found, a known error is registered. The known errors are regularly reviewed in the error control phase for a possible resolution. Timing of the error control phase can be very long to very short. For some problem resolutions, it might be required that a business case is presented to justify the resources to resolve the problem. The practice success factors for problem management. What is a practice success factor? A practice success factor is a complex functional component of a practice that is required for the practice to fulfill its purpose. For the problem management practice, we have the following practice success factors. Identifying and understanding the problems and their impact on services. Optimize problem resolution and mitigation. More in-depth details around the practice I'm not going to cover. Please check out section 2.4 or subsection from the practice. Now more on the measurements of the success factors for the problem management practice. The effectiveness and performance of the ITIL practices should be assessed within the context of value streams to which the practice contributes. I will talk more about value streams a bit later in this video, but keep in mind what I just said. The problem management practice contributes to value streams. Now the metrics for identify and understand the problems and their impact on services. Number and impact of problems identified over the period. Number and impact of incidents that are not associated with known errors. Number and impact of incidents that require urgent problem investigation. The metrics for the second practice success factor, optimize problem resolution and mitigation. Number and impact of incidents prevented by problem resolution. Number and impact of incidents resolved with solutions provided by the problem investigation. Number and impact of known errors that remain open. More on the metrics you can find in section 2.5 from the problem management practice. Next up, the dimensions of service management, starting with the value streams and processes. First, a few definitions. Process. A set of interrelated or interacting activities that transform inputs and outputs. A process takes one or more defined inputs and turns them into defined outputs. Processes define the sequence of actions and their dependencies. Management practice. A set of organizational resources designed for performing work or accomplishing an objective. Service value stream. A series of steps an organization undertakes to create and deliver products and services to consumers. For the problem management practice, we have 4 processes. Proactive problem identification, reactive problem identification, problem control, and error control. In the next slides, I'm going to talk about the processes in more detail, but still very limited. This all comes from the problem management practice, section 3. The proactive problem identification process creates the following outputs: problem records and feedback to the problem initiator. To create the output, we have the following key activities: review of the submitted information, problem registration, and initial problem categorization and assignment. As with any process, we need to have an input to create an output. For the proactive problem identification, we have the following inputs: Error information from vendors and suppliers. Information about potential errors submitted by specialist teams. Information about potential errors submitted by external or internal users and professional communities. Monitoring data and service configuration data. For the second process, reactive problem identification, we have these key activities: problem registration, initial problem, categorization and assignment. With these activities, we create problem records as output for the next phase. To create the problem records for the reactive problem identification phase, we require following inputs: information about ongoing incidents, incident records and reports, monitoring and service configuration data, service level agreements. The third process, problem control. For the problem control process, we do problem identification and problem investigation to create following outputs: problem records, known errors, and incident solutions. To be able to run this process, we require a few inputs, such as incident and problem records, monitoring and service configuration data, technical information about CIs, products, and services. For the fourth process, error control, we have these key activities: problem solution development, problem resolution initiation, known error monitoring and review, and problem closure, which results in the following outcomes: problem models, change requests, improvement initiatives, and problem solutions. To enable this, we need to work with the following inputs: problem and incident records, service configuration, knowledge management, and monitoring data, technical information about configuration items, products, and services. Something to add here: problem closure is applicable in the following situations: the problem is solved or the problem does not affect the organization anymore. For example, the impacted application is not used anymore. Value streams are very important. They turn in the end a demand or opportunity and value for the stakeholders. Value streams are supported by the various practices to create the value. Value streams are, like everything in the service value system, subject to continuous improvement. To improve value streams, we do value stream mapping. We execute following steps as part of the value stream mapping. The first step: identify the scope of the value stream analysis. It can be mapped to a particular product or service or applied to most or all of them. If the value stream is not clearly identified, you might first want to take a step of identifying the value streams. The second step: define the purpose of the value stream from a business standpoint. Do not just look at it from the practice, but look at it from the business. What are the stakeholder needs and wants? The third step: do the service value stream work. Consider the lean technique of Gemba. Identify the workflow steps. Also look at possible inputs from other practices. Collect data as you walk. Evaluate the workflow steps. Map the activities of the information flows. Create and review the timeline and resource level. Map out process times and lead times for resources and workflow through the workflow steps. Step 4. Reflect on the value stream map. Identify factors that might not have been entirely apparent at first. The information collected is used in this step to find the waste, not only for the service practice. Other steps from other practices might be involved in creating waste. Step 5. Create a to-be value stream map. This informs and drives improvement. The value stream should be considered holistically to ensure an end-to-end efficiency and value creation, not just local improvements. Step 6. Use the to-be value stream map. This is also the point where we plan improvements, for instance updating problem management models as part of the review. Refer to Continual Improvement Practice Guide for a practical improvement model. More about value streams and processes you can find in Chapter 3 of the practice. The organization and people dimension. The roles in problem management practice. The structure and naming of each role may differ from organization to organization, so any roles defined in ITIL should not be treated as mandatory or even recommended. Keep in mind, roles are not job titles. One person can take on multiple roles, and one role can be assigned to multiple people. ITIL makes use of the LACMT model. L. Leader. Decision-making, delegating, overseeing other activities, providing incentives and motivation, and evaluating outcomes. A for administrator. Assigning and prioritizing tasks, record-keeping, ongoing reporting, and initiating basic improvements. C for coordinator, communicator. Coordinating multiple parties, maintaining communication between stakeholders, and running awareness campaigns. M for methods and techniques expert. Designing and implementing work techniques, documenting procedures, consulting on processes, work analysis, and continual improvement. T for technical expert. Providing technical subject matter expertise and conducting expertise-based assignments. The position of the letter in the profile indication indicates the importance of the capability for that role. For example, the problem manager has CLMT profile, coordinator, leader, methods and techniques expert, and technical expert, which means coordination is the most important skill. Next required but less important skill would be the leading skill, and so on. The common roles of the problem management practice are problem manager and problem coordinator. The problem manager is responsible for managing and coordinating the specialist activities in the problem management processes, including conducting and coordinating problem registration based on submitted information, the initial categorization of the problems, coordinating problem investigation and solution implementation control, coordinating the communication within the teams responsible for incident resolution and change implementation, developing and communicating problem models where applicable, coordinating known error monitoring and review, the formal problem closure. In more complex organizations, some responsibilities for the problem management practice may be delegated to the problem coordinator. The problem coordinator focuses on routine problem management activities, such as the review of submitted information about possible problems, problem review, and problem closure. The technology and information dimension. Automation solutions for the problem management practice. In general, these applications are used across the organization, not just used by the problem management practice. Workflow management and collaboration tools we use for reactive problem identification, management of problems and known error records, support of collaboration during problem investigation and resolution, support of problem impact analysis and root cause analysis. Monitoring and event management tools are used for proactive problem identification, support of trend analysis for problem impact assessment, and monitoring of the effectiveness of the resolution. Service configuration management tools are used for the problem categorization and investigation. Analysis and reporting tools are used for problem identification and practice measurement and reporting. Knowledge management tools are used for retrieving, managing, and communicating known solutions for incidents and problems. Recommendation for automation of the problem management practice. Distinguish between problem control and error control. Whether problems and known errors are different objects or different statuses of the same object in the automation tool. Make sure they support clear separation between investigation, problem control, and periodic review and resolution. Ensure integration with other practices. At the least, it should be possible to link problem records to incident records, change records, configuration items, and services. Ensure integration with knowledge bases. At the least, information about errors and related recommendations should be available. Consider integration of the vendors and suppliers' knowledge bases, bug reports, release notes, and so on. Pay attention to measurement and reporting from the beginning. Ensure visibility of the problem management status and progress, including the 4 processes: reactive and proactive identification, problem control, and error control. Leverage machine learning capabilities. Problem identification based on incident records or on monitoring data, cause-effect analysis, impact analysis, search for resolutions, and other activities problem management practice can be automated with the use of machine learning. Automate monitoring of known errors. For known errors requiring periodic control, the conditions of control can be defined for automation monitoring. For example, if the error is accepted to be resolved after a software update is released by a vendor, it is possible to automate monitoring of the updates and notification or assignment to a relevant specialist. The partners and suppliers dimension. There's nowadays not an organization delivering services all on its own. Partners and suppliers may support the development, management, and execution of the problem management practice. The forms of practice support the following. Performing problem management activities. Third parties are often involved in problem investigation and resolution. It is important to ensure effective integration of these third parties in problem management workflows and information exchange, as well as their adherence to the relevant policies. Some problem management activities can be largely or completely performed by a specialized supplier. Provisioning of software tools. Most software tools used for problem management are shared with other practices. Problem management is never the first practice to be automated and rarely one of the most important. Consulting and advisory. Specialized suppliers who have developed expertise in problem management can help to establish and develop the practice and initially develop the problem models. Capability assessment and development of the practices. ITIL defines 5 levels in a capability assessment or maturity. An internal assessment can be done to validate how the practices are performing, highlighting areas for improvement. Not every practice has to be at the maximum level 5. This would be very resource intensive and costly for the organization. You have the following levels, from the lower level to the higher maturity levels. Level 1. The practice is not well organized. It's performed as initial or intuitive. It may occasionally or partially achieve its purpose through an incomplete set of activities. Level 2. The practice systematically achieves its purpose through a basic set of activities supported by specialized resources. Level 3. The practice is well defined and achieves its purpose in an organized way, using dedicated resources and relying on inputs from other practices that are integrated into a service management system. Level 4. The practice achieves its purpose in a highly organized way, and its performance is continually measured and assessed in the context of the service management system. Level 5. The practice is continually improving organizational capabilities associated with its purpose. In the next slides, I'm going to mention all the criteria which are defined for the practice success factors. Each criterion is linked to one of the 4 dimensions. I list the maturity level out on the slides, but you can find these back in the practice book. First practice success factor of the problem management practice. Identify and understand the problems and their impact on services. I will not mention the criteria in the order on this slide, but group them by the dimension, starting with the value streams and processes. The causes of important incidents are identified and investigated. The errors in products and services which might lead to incidents are identified and investigated. Problem identification and control address the errors in value streams, processes, and other workflows. Problem identification and control are integrated into value streams. The effectiveness of problem identification and control is measured and reported. The effectiveness of problem identification and control is regularly reviewed and continually improved. For the second dimension, organization and people, we have one criterion. Problem identification and control address the errors within the organization. For the partners and suppliers, we have the following criterion. Problem identification and control address the errors in third-party services and dependencies. And the last criterion for the information and technology dimensions, problem identification and control address the errors in technology solutions. Problem identification and control information is tracked and managed using an integrated information system. For the second practice success factor, optimize problem resolution and mitigation. Again, I'm starting with the value streams and process dimension. Where reasonably possible, errors in products and services are fixed. Where errors cannot be fixed, they are controlled and mitigated. When error resolutions are considered, they address value streams, processes, and other workflows. Known errors are regularly reviewed and the relevant information is updated. The effectiveness of the error control is measured and reported. The effectiveness of control is regularly reviewed and continually improved. The criterion for organization and people dimension. When error resolutions are considered, they address the organization and competencies. One criteria for the partner and supplier dimension. When error resolutions are considered, they address third-party services and dependencies. At last, the information and technology dimension, we have two criterions. Information about known errors is tracked and managed using an integrated information system. When error resolutions are considered, they address the technology solutions. My last slide, some recommendations for the success of problem management practice. Start logging problems now. This starts to build up data. This also gets people to think about long-term problems and remove barriers to getting them raised and fixed. They might, for example, be concerned that they will have to take on the problem and so not log it. Think carefully about getting the right people in problem roles. The people doing problem management roles and tasks need to have the right skills and attributes for the relevant phases. This includes data analytics, reporting, trend analytics, and so on. Problem management is not an administrative role. Some administration skills are required to manage work and promote issues, but this is not the main function or value of problem management. Problem management won't simply work by itself, particularly when starting the practice. That needs drive and focus. Publish a list of business problems. Transparency of current high problems ensure focus and shared goals. Everyone should know the top list problems. Open visibility also helps you use the cumulative experience across a team to speed up ideas and actions for resolution. Get customer input on their problems. It is essential to get end-user feedback on their problems, which also might not be defined or logged. It is also beneficial to get an external view on what really matters to the business. The problem manager or problem team won't fix all the problems. Problems need to be owned and acted upon by the whole business. Problem management facilitates fixes rather than delivering all technical fixes. Those raising problems are not necessarily the same as those who will fix it. Prioritize problems in the order of value to the organization. Risk, opportunity, cost, and quality should drive prioritization, not technical or team focus. Problems should be highlighted in business terms for approval, decision, or action. Problem management needs a swarming approach. Problems will often be raised through a tiered support model, but this is not always effective when collaboration and management support is needed. All technical teams should be expected to participate in collaborative problem-solving activities and swarm teams. SLAs don't apply to problems, but problem management improves service quality. Problems are not predictable and don't always follow a linear process. Problem management should be measured and appreciated as a contributor to business value. For reporting, problem management can also be used to drive improvement targets for the incident resolution. Use AI and automation tools where possible. AI can interrogate data to identify trends, for example. AI and robotic process automation can be used to remove repeat of the underlying issues. We reached the end of this video, and hopefully you used it as an audiobook. I hope this was useful for you and is helping you on your ITIL4 journey. If you've already done some of the studying, you will know I did not cover everything. I at least did not cover the subsections of section 2.4, for example. Thank you so much for watching this video or listening to watch the audio. Cheers, bye.